The last topic we'll cover in this remote lecture, our only remote lecture of the year, are exponential functions. Functions that are y equals a to the x, where a is some positive number. If a was not a positive number, this function is weird, ever so weird. So we only allow positive bases for our exponential functions. Don't forget the properties of these exponential functions. What we care about is the derivative of a to the x. So let's use limits to figure out what the derivative of a to the x is. It's the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x, just the slope between 2 points on the curve as those 2 points become infinitely close to each other. Plug that into a to the x. We get that expression right there. We can use this property right here to rewrite our first term. A to the x plus delta x will be a to the x times a to the delta x. Which allows us to factor out a to the x. We can factor a to the x out. And since a to the x does not have a delta x in it, when we factor it out, it can leave the limit entirely. Because for the limits, delta x is the variable. And since a to the x does not have a delta x, we can factor it out all the way. This is interesting. Why is it interesting? Because this means that a to the x differentiates to itself times some constant. And why is this constant? It's constant because there's no more x's in there, right? All of the x's were factored out, which means that this limit is going to equal some number since there's no more x's in there. And so a to the x differentiates to itself times a constant. Furthermore, that constant depends on a. The constant depends on a because that's all that you can change in here, right? A is the only changeable aspect of this limit. So as you change a, so too do you change the value of the constant, which means that a to the x differentiates to itself times some number which depends on a. The natural question is, what value of a makes that limit equal 1? Because if that limit equaled 1, then for that number a to the x would differentiate to itself times 1. So some number a gives you an exponential function that differentiates just to itself. And so the way to do this, there's multiple ways to do it, but one way to do it is this process called linear interpolation, which is essentially guess and check, but like in a more organized approach, where you just guess the value of a. And if this constant was less than 1, then guess a bigger value of a. And if it's more than 1, go a little bit smaller. And you keep kind of like fine-tuning your guesses until you figure out what number gives you exactly 1 for that limit. It ends up that the number that gives you 1 for that limit is a equals like 2.718, etc., etc.